Yeah.
meet soon once Corona is over. So let me quickly share my screen. Is it visible, my screen?
Yes.
And it's the correct screen, right?
Yep. Everything's perfect.
Cool. Cool. Sometimes we end up sharing the wrong screen and it's all funny. So, yeah. So, hello everyone. I'm Ankita, and today I like to share my views and what change detection and Angular is. So, I see a lot of you have already reached the binding stage and adding items in to-do list and must be wondering how you change something in the component and it gets updated in the HTML. Like, what's the magic going on there? So, what exactly is change detection? So, whenever we change any state in the application, it is reflected in the user interface or the DOM. So, what like this what can this change triggered be? How can it be triggered? It can either be a browser event like when you click a button or submit a form or something like that, or when you make ajax requests like when you try to fetch something from the database or call an API, or when you have some timers like to run a specific section of code after some timeout, like that. So all these are async events. So I have a small application. Let me try and zoom in a little. So this is a very small HTML which says a title, and when I type something in, it is reflected here. How? Because I'm just clicking a button and giving a text. How does Angular know? Like, okay, some event happened and I have to make some changes in the HTML. I have to reflect those changes. How does Angular know? So let's go back to see how. So in Angular, our whole application is built up like component trees. Just like our web applications in HTML, we have DOM trees. All the elements are built in a tree-like structure. In Angular, we have a component tree. So we have the app component and then we have its child components. And data always passes from the root component to the child components. So data passes from app component to its message component and then to another message component, like that. So it always flows from the parent to the child, not vice versa. Like data cannot flow from child to parent. So this is also called unidirectional flow. Now, how does it happen? So every component, we see a component here. So every component has an associated change detector, which uh, which basically detects a change in a component. If something is triggered, if an async event is triggered, then this change detector comes into play. And it all so if in the GIF you'll see the event is triggered here in the bottom rightmost component, but the whole change detection is triggered from top to bottom for each of the component. Like change happened here, but the whole tree, all the components are checked to see if there is any change that happened and if they need to be re-rendered again, or if the HTML needs to be updated again. So it starts from the root component and then it's triggered down to the child components and it's repeated again. Uh, but how does Angular know like a change happened, an async event happened, and now there is something that it needs to do? For that, there are zones. What are zones? They are execution context for async events. So for any async event that happens, whether it's a button click or you call an API, all those events runs inside zones. So initially a zone is stable. As soon as an async event runs inside the zone, the zone becomes unstable. So if I click a button, it creates its own new zone. It becomes an unstable zone, and when the button click is finished, the zone becomes stable. Now, as soon as the zone becomes stable, it emits an event which is on turn done event. Now, Angular listens to this event and it knows, like, okay, now my async event has finished, and it triggers a tick function. And this tick function then goes and checks all the components and see if the old value of the component is different from the new value. If it is, then it marks it and updates the DOM. So basically, for any async task, it is run inside a zone, and as soon as it is finished, there is an event that Angular listens to, which is tick, and then it runs the change detection cycle. So it happens for all the components irrespective of where the event occurs. So this can be sometimes have performance implications. So we might not want the whole tree to have this change detection triggered. We can do it manually also. So we can configure a component to run change detection when we want. For that, we have a change detection strategy, which is on push. So for a component, if you see in the image here, there is a change detection which is strategy which is on push. So whenever an event happens, this component and its child components won't be checked for any changes until and unless any of its input reference has changed, or its child has triggered an event, or you manually go and trigger an event. So in all these cases, you have only then the change detection happens. Otherwise, this component is not changed. So this is a very brief overview and summary of how change detection happens. If you have any questions or suggestions or any input that you want to, please go ahead. But like, this is what I wanted to share.
Are there any questions? I love this topic because I was always wondering what the zone is doing and just know a little, but as in every workshop I learned something new. And now I learned that the zone has become unstable, so that's quite interesting. Anyone have a question? Don't be shy.
No, I just have a small info for you guys that actually I got this question about zones at some interview and I've never heard about them, so it's good to remember just so you know you can say, oh, I've heard about it. You know, even though you don't totally understand, you know that you can actually trigger the change detection yourself in your code, and actually in a huge application, it's really useful. So a great topic.
And also a very important thing to remember here is to see how actually things work under the hood. Like, once you start learning a language, try to ask questions. Why is this happening? How is this happening? Which will help you get a better understanding of things like these. So yeah. But thank you so much for listening so patiently and attentively. Yeah, this is all I had to share.
Ankita, for those who never know the previous version of Angular.js, they know change detection can be a huge issue in big applications, and with small things you can have the magic that everything is updating automatically, but sometimes it can get a mess. So that's the reason why it's good to know about it, and it's cool that we not always have to do it on our own. So thanks, Ankita, and I will